As most of you know, I'm Liz John with SPEAR. Thank you for joining this morning's SPEAR Speakers Bureau webinar. We are a nonprofit and we work to advance energy efficiency in Texas and Oklahoma. And as a part of that, our Energy Codes program promotes compliance with state energy codes through training, outreach, and peer support. And with that, we bring you these Energy Code webinar sessions every other Wednesday morning. So today we have Marty Ward with PEMA, and he will be presenting on re-roofing requirements for commercial buildings in the 2015 International Codes. Just a few reminders before we get started. All attendees are muted. If you have a question, please type it into the Q&A panel and we will answer it at the end of the webinar. If by some chance we run out of time, I will forward that question and copy you to the speaker so that they can answer you directly. These webinars are IECC certified, so if you're watching right now and you're interested in being issued a certificate, after the webinar, I will send you an evaluation survey. And for those of you who complete the survey, you will receive an IECC CE certificate. Please give me a few days to get that out. And with that said, I will go ahead and introduce Marty. Marty Ward began his career in the roofing industry in 1990. He started working for a roofing contractor as an installer of both low and steep slope roof systems. In 1995, he began his career with GAF, where he held various positions, including field inspector, Midwest Senior Quality Assurance Representative, Midwest Regional Technical Manager, and more. Now serves as GAF's Senior Codes and Regulatory Compliance Specialist. Marty has earned a Bachelor of Science degree in Occupational Safety and Health from Illinois State University and a Master of Science in Industrial Management from Northern Illinois University. So with that said, Marty, I'll go ahead and take it from, turn it over to you if you want to go ahead and take the screen.
Okay.
Now we'll let you know how it's looking on our end.
Happy Hump Day, everybody.
Yeah.
Getting this. We up there, Liz?
Perfect. It looks good.
All right. As Liz mentioned, this is a presentation presented by PEMA, which is the Polyiso Insulation Manufacturers Association. Today we're going to go over the re-roofing requirements for commercial buildings in the 2015 International Codes. The slide says that this presentation has been approved for AIA credits for continuing education. So if you're an architect out there, this would qualify as a continuing education unit. Here's a course description for today's webinar. Basically, most of the I-codes are based on default requirements for new construction. Roofing, however, is different. Most of the roof systems installed on U.S. buildings end up on existing buildings, not new. Re-roofing is one of the most common construction projects, and most U.S. buildings will have three or more roof systems during their useful lifespans. While the International Building Code contains basic material requirements for covering assemblies, other provisions, God bless you, provisions for re-roofing can be found in the International Energy Conservation Code. Recent clarifications and reorganizations to the IECC for re-roofing have improved the clarity of the code requirements, but given the need to coordinate the provisions across three codes, many users of the codes will benefit from this re-roofing review. Here are the learning objectives for today's webinar. Hopefully by the end of this course, you'll be able to enforce the provisions for roof recover and roof replacement, understand the International Building Code provisions and the definitions for re-roofing, be able to properly apply exceptions to Energy Code re-roofing requirements, and enforce the Energy Code provisions for roof replacements. Again, My name is Marty Ward. Welcome to the PIMA Educational event for re-roofing. Today I'm going to present information on how the energy code applies to re-roofing in the real world. Thanks everybody for taking the time to attend today's webinar. My name is Marty Ward. I am the Senior Codes and Regulatory Compliance Officer with GAF. GAF is a roofing manufacturer here in the U.S. So we're going to get going. The International Code Council is responsible for the development and maintenance of model construction codes in the U.S. and abroad. Because of their growth, the IECC has become the single most important model code developer in the construction arena. With the tremendous variety of codes covering everything from chimneys to septic tanks and everything in between, the IECC has created a family of coordinated codes that govern all aspects of the construction process. We'd like to thank the IECC for the code experts that we're going to be using here in today's presentation. So the importance of re-roofing and energy efficiency cannot be overstated. If roofs are replaced every 40 years and maybe somewhere along that 40-year timeline it's recovered once in between, you can see that we can't miss the rare opportunity to reduce energy consumption. But let's not forget that roofing is one of the most common renovation projects, and roofing projects represent one of the most common building permitting activities. Most new roofs are installed on existing buildings. I can't stress that enough. Bringing the roof assembly up to today's code standards, for whether it's for structural performance, energy efficiency, or fire testing, is an opportunity that is provided only once every decade or two. And taking advantage of this opportunity can pay significant dividends. For example, an analysis of a typical existing building show that replacing the roof with code compliant assemblies reduced the whole building energy use by an average of 5.7%. These savings can add up quickly on a state or even national level, resulting in significant cost savings for building owners and reduction of CO2 emissions. So why does re-roofing matter? Well, the low-hanging fruit on energy efficiency is not found in new buildings. It's in our existing building stock. Every year, billions of square feet of new roof coverings and assemblies are installed in the U.S. But more of those roofs are installed on existing buildings, a lot more. As this pie chart shows, in 2015, approximately 64% of all roofing activity for low-slope commercial roofs involved re-roofing. If we only focus on new construction to impact energy efficiency in our nation's buildings, it's going to take quite a while. In fact, many existing buildings have insulation levels dating back decades, so ensuring energy compliance to the code requirements for re-roofing is the best way to reduce future energy consumption. But it's also important to consider that a new roof can upgrade the building's performance when it comes to fire, wind resistance, as well as improving the management of water. We're going to focus on the commercial requirements in the 2015 International Energy Conservation Code, but since we are talking about re-roofing of existing buildings, we would also like to talk about the technical requirements from re-roofing apart from the energy code requirements. That means we'll show you how the existing building code and re-roofing sections in the International Building Code fill in the blanks. To properly frame this discussion, we're going to look at the definitions related to roofing and re-roofing to help you gain a better understanding. If we don't get the definitions, we can't get the scope of the code. We'll also look at the requirements for roofing in the building code and existing building requirements, which include re-roofing in the International Existing Building Code and the Energy Conservation Code. We'll be looking at Chapter 15 in the International Building Code, which is the Bible for re-roofing requirements, and the Commercial Energy Code, energy efficiency requirements in the IECC. So let's review the definitions from the International Building Code. First one here is roof repair. That is the reconstruction or renewal of any part of an existing roof for the purposes of its maintenance. The picture here is an example of a roof repair, potentially maybe even two separate repairs. Looks like there was some drain work done, probably as a result of a leak, so they reflashed the drain. And then someone came in with some elastomeric coating and hit around that penetration pipe and along the sidewall. So re-roofing is the process of recovering or replacing an existing roof covering. Roof recover, so there's two different options when you are re-roofing. You've got a roof recover option or a roof replacement option. The roof recover is the process of installing an additional roof covering over a prepared roof covering without removing the existing roof covering, meaning it's an overlay of the existing roof system. A roof replacement is the process of removing the existing roof covering, repairing any damaged substrate, and installing a roof covering. So both roof recover and roof replacement are considered re-roofing. Some of the code provisions apply one or the other of these activities, and other requirements apply to both. Knowing the difference makes all the difference. So if you learn one thing today, these definitions are at the top of the list. So roof recover, the process of installing an additional roof covering over prepared existing roof covering without removing the existing roof covering. Here's a few examples of roof covering. Note that the metal panels are being installed over some additional supporting frames. We're going to hold that thought and we'll double back and discuss that later in today's session. In the photo on the right, as you can see that, is there someone not on mute? I got a lot of feedback going on. Thank you. Sounds like it got better. The photo on the right is the asphalt shingles are being installed over an existing layer of shingles. Building code in most cases only allows for 2 layers of roof coverings. Here's a photo of roof replacement, which is the process of removing the existing roof covering, repairing any damaged substrate, and installing a new roof covering. This photo shows a roof replacement in process. In this case, the roof covering assembly is in the process of being removed down to the wood deck. This photo shows a new installation. As you can see, the cover board is being installed over polyiso sanyard insulation board. Note the installers are able to walk on the installation surface. This is one of the benefits of using polyiso board. So let's look at the other definitions that relate to roofing. So roof assembly is a system designed to provide water protection and resistance to design loads. The system consists of a roof covering and roof deck, or a single component serving as both the roof covering and the roof deck. A roof system includes the roof deck, an air vapor retarder, a substrate or thermal board, insulation, and roof covering. The roof covering is the covering applied to the roof deck for weather resistance, fire classification, and appearance. The definition of the roof deck in the IBC is the flatter sloped surface constructed on top of the exterior walls of a building or other supports for the purpose of enclosing the story below or sheltering an area to protect it from the elements, not including supporting members and vertical supports. So some examples of roof coverings are asphalt shingles, single-ply membranes, TPO, EPDM, modified bitumen, built-up roof coverings, or concrete tiles, for example. Some examples of common roof decks are OSB or plywood, sheathing, metal, and concrete. And then a metal building, the roof panel may serve both as the roof deck and the roof cover. There are several types of insulations used in roofing. For low slope systems with insulation, polyiso is the most common. It provides the best R value per inch of thickness. There are other types of products available, including other foam plastics such as expanded polypyrene and extruded polystyrene, and mineral wool fiber, which is more easily compressed and thus less resistant to damage from foot traffic or material storage during the construction of the roof. Rigid insulation board is one of the most common applications for low slope systems. Tapered insulation allows the roofing contractor to slope the roof toward interior drains. It also provides a fix for re-roofing scenarios that may have issues with height of other building features and required insulation thicknesses. Here's a couple of layouts, typical layouts of tapered insulation on the screen. This slide shows a cross-section of how tapered insulation boards fit together to provide a uniform slope for the roof covering. Note that it's important to stagger the insulation joints to reduce heat flow. Each insulation layer is further offset to make sure the roof has optimal thermal resistance. Tapered insulation could also be used to create saddles that direct rainwater toward the drain scuppers or gutters. This slide shows a potential location for a roof saddle. The inset and in the lower left of the screen shows a completed insulation saddle. Tapered insulation can also be used to create crickets on the upslope side of things like the skylights or penetrations to help the flow of water around these penetrations. Okay, so let's take a look at the International Building Code Chapter 15 requirements. Here are the re-roofing provisions. There's an additional exception not shown that addresses the need for scuppers when re-roofing. This text provides the assumption that the structural system in place has to support the loads of the roof materials as well as equipment on the roof during the re-roofing project. What is most important here is the requirement to meet the provisions for roof coverings found in Chapter 15, which cover the important performance issues, including fire and structural performance. So Chapter 1511.3 is roof replacement. Roof replacement shall include the removal of all existing layers of roof coverings down to the roof deck. There is an exception for ice barriers that are typically adhered directly to the deck, so it is allowed to recover an existing ice and water shield one time without having to remove it. Now we're going to switch over to roof recover, which is 1511.3.1. The installation of a new roof covering over an existing roof covering, and it shall be provided when, one, the new roof covering is installed in accordance to the roof covering manufacturer's approved installation instructions, and two, The complete and separate roof systems such as standing seam metal roof panels that are designed to transmit roof loads directly to the structural components of the building and that do not rely on other existing roofs and roof coverings for support shall not require the removal of the existing covering. What that's saying is if it's a standing seam metal type roof that is the roof deck and roof covering, you don't have to remove the existing metal prior to recovering it. Remember that the definition includes the installation over a prepared existing roof covering. That means nothing is removed, but the surface may be prepped. It may get cleaned and cut. And there is for the application of new protective coating over an existing sprayed polyurethane roof can be done without tearing off the existing roof coverings. Those coatings are adhered directly to the sprayed polyurethane. So if they're wearing out and getting close to their useful life, you can coat over them without having to tear out the spray polyurethane foam as well. Note the provisions of the 2015 and 2018 International Building Code clarify that roof recover in accordance to approved manufacturer's instructions shall be permitted. This provision only applies to the International Building Code Chapter 15 requirements. It is important for listings for what fire and wind performance are based on assembly tests that include insulation decks and cover boards. Now, the I codes always allow for the use of Chapter 1, which are alternative means and methods as a way of dealing with issues. And given the variety of roof covering systems in the market and on existing buildings, this provision was added to provide additional guidance to the code official. If a manufacturer brings you a recover option to the permit desk and it isn't covered by the code, ask for the installation instructions and the appropriate test reports. Here, this is the clarifications of the 2015 International Energy Conservation Code. Here's a brief history lesson. The detailed requirements for re-roofing back in the 2012 International Energy Conservation Code read as follows. Re-roofing for roofs where neither the sheathing nor the insulation is exposed. Roofs without insulation in the cavity and where the sheathing or insulation is exposed during re-roofing shall be insulated either above or below the sheathing. With this language back from the 2012 IECC, the code included an exception to an exception. And this item actually included two different exceptions and also gave zero guidance on how to meet the intent of the code. Exceptions to exceptions in code language is an invitation for a little bit of chaos from the code official side. The biggest problem with the old language is it's about re-roofing, which includes roof recovers and roof replacements, which are two totally different types of projects. It also mixes in language that applies to steep slope roofs and uses terms like cavity without specifying which cavity and uses sheathing instead of roof deck. Additionally, it's stated under some conditions listed, roofs shall be insulated either above or below the sheathing. That requirement didn't say that what the insulation requirement is. It also doesn't address what to do if the cavity is exposed and the ceiling has R11 bats across above the ceiling. So does that mean no extra insulation is required? The code could have been interpreted in many different ways. The language was a bit of a mess. But thankfully, in the 2015 and 2018 IECC now contain a fix, at least for low slope re-roofing insulation above, with low slope re-roofing with insulation entirely above the deck. The change to the 2015 IECC didn't change the code, it just made it easier to understand for projects, at least with the insulation entirely above the deck. We'll get to that in a minute, but what did change in the code? Definitions from the building code carried over to the IECC as a basis for roof replacement, clarifications on insulation requirements. Roof repair and recover are exempt from the building envelope requirements, provided the modifications did not increase the energy use of the building. Back where you all are located down in the south and pretty much climate zone 2 and 3. I mean that would, if you've got a white roof, chances are the energy use of a building would increase if you were to put a dark color roof on it. And the third change in the code is the roof cover and roof replacement are exempt from air barrier requirements. The 2015 IECC clarification for roof replacement is located in C503.3.1. And it states that roof replacement shall comply with table C402.1.3 or C402.1.4, where the existing roof assembly is part of the building thermal envelope and contains insulation entirely above the roof deck. This new language uses defined terms in the International Building Code and now in the International Energy Conservation Code. It applies only to roof replacement and only when the roof assembly is part of the thermal envelope. And it also gives clear guidance to the mandatory language in the new roof assembly that must meet the R value or U factor table, which are the two tables listed in 503.1.3.1. This code clarification was submitted to adjust low slope roofing only. Hopefully we'll see other future code proposals to clarify other conditions such as metal buildings, but that's for another day. Another change in the 2015 IECC was a correlation between ASHRAE 90.1 and the IECC. For the first time, the R value and U factor requirements in insulation entirely above the roof deck are the same. Since re-roofing is the largest portion of the roofing market, it seems more important to get this correlation in place. With new construction, we could look at the entire building envelope, so minor differences in R values for roofs and walls between the two standards isn't that big of an issue, as long as the overall building envelope averages out. Roofs, because of the market for re-roofing, require consistent performance requirements between the International Energy Conservation Code and ASHRAE 90.1. As I said, you all are down in climate zone 2 and 3, so looks like R25 would be the requirement in most of the areas for the spare members. So what about ASHRAE? Well, the International Energy Code as a model code does does include several options for compliance. Compliance with ASHRAE 90.1 is one of those options. The IECC also includes prescriptive and performance paths to meet energy efficiency provisions. Let's look at the actual scoping language in the IECC. The IECC scope is found in section C 401.1. The code gives us three options, which are not interchangeable, by the way. Those options are to use ASHRAE 90.1 or the performance or prescriptive path. Most roof replacements are standalone projects, so using the prescriptive path is typically the easiest way to meet the energy code. Now, ASHRAE 90.1 does contain similar language to the International Energy Conservation Code. Recent additions to bring definitions for re-roofing help clarify those requirements, and 90.1 does require consideration of the roof insulation for roof replacements. ASHRAE 90.1 is not as well coordinated with the building code or the existing building code as it is with the International Energy Conservation Code, but the requirements are clear. In summary, this slide shows exceptions to energy efficiency requirements, and the next slide will show what is required. Repairs are exempt from most new building provisions, provided the repair does not diminish life safety. Roof replacements where insulation is beneath the roof deck or in the attic cavity are not required to meet new insulation requirements if the cavity is not exposed during the project. Now here is what is required for re-roofing. New roof coverings must meet code requirements for structural, fire, and weather protection. The new roof coverings must not increase the energy use of the building. Roof replacements where insulation and or roof deck is exposed shall meet the insulation requirements. This language is now very clear for low slope roofing with insulation entirely above the deck. Now PEMA has developed a re-roofing checklist for your use. It covers these items and could be integrated into your permit system as well as assist you on plan review and inspection. This is something I already provided to Liz. It's there for use if you want it. I guess you could either email myself or Liz to get a copy of it. Next couple of slides are going to go over the checklist itself. So here's what the checklist looks like. You know, the first page is essentially project details, where the second page gives you the definitions and the sections of codes that it pertains to. So the checklist includes specific types of recover allowed, where the new roof covering is installed in accordance to the roof covering manufacturer's approved instructions. Where metal panels or shingles or concrete or clay tile can be installed over existing wood shakes, provided there is a thermal barrier there, and then new roof coatings over sprayed urethane roofs. So recover is allowed if there are less than 2 layers and the existing roof covering assembly is not water damaged or deteriorated. Recover is not allowed on existing roof coverings that are slate, clay, concrete, or asbestos cement tile. The recover requirements state that the new roof covering assembly must meet all requirements for new construction except energy performance if the energy use of the building is not increased. Roof reflectance requirements depends on the climate zone and the existing roof covering. I know down in climate zone 2 and 3, you're required to have a certain roof reflectance for the covering to conserve energy usage. When replacing the roof covering, the building code applies to any existing roof coverings to be removed down to the roof deck. The new roof covering assembly must meet all the requirements for new construction. This includes roof insulation for roof assemblies that are part of the thermal envelope and contain insulation entirely above the roof deck. The requirements for roof reflectance depends on the climate zone and the existing roof covering. It is important to note that existing insulation in acceptable condition is not required to be discarded and can be reused as long as there's no questions about its suitability for use. Remember that new roof coverings are tested as part of an assembly that includes insulation. So if the existing insulation is reinstalled, new additional insulation may need to be added to bring the project into compliance with the energy code. Here's another cutout of the re-roofing checklist. So why is roofing important? Because roofing is one of the most common renovation projects and because most new roofs are on existing buildings. So it's obvious that bringing roof assemblies up to today's code standards, whether it's for structural performance, energy efficiency, or fire testing, is an opportunity that is found once every 10, 15, 20, sometimes 30 years. Roofs are the first line of defense for buildings against many threats, including fire, wind, water, and for most buildings, the roof has the largest surface area. That is why taking advantage of the opportunity to add insulation is important, and that is why re-roofing requirements have been added to the International Energy Conservation Code since the beginning. That is all I have for you folks today. Thank you for, again, for taking the time out of your hump day morning to listen about, hopefully learn a little bit about re-roofing or roofing and how it relates to the codes. Here's my information. If you have any questions afterwards. Liz, I'm gonna hand it back to you now.
Sure. Thank you, Marty. That was great. Just a reminder that I will send out course evaluations to everyone that attended. And if you do want that ICC certificate, please fill out the evaluation. Let's see. Our next webinar will be Wednesday, February 6th. And I do have just a few questions. The first being, would the requirements differ for jurisdiction that has not adopted the existing building code?
Yeah, I guess it depends on which version of the code is required in a given jurisdiction. Earlier energy code versions had lesser R value requirements as a 2015 does. So
okay.
I guess the short answer is yes, potentially.
All right. And will a white TPO roof always meet the roof reflective requirements?
Yes. I mean, that generally speaking, yes. It's white roofs are going to meet the minimum reflectivity.
Sure. And we have one more here. So I hear roofing contractors, let's see, whine about curb heights and other difficulties in increasing the insulation on a roof cover. Can you talk a little bit more about that?
That is sometimes a challenge, especially on older buildings where you have limited height on penetrations or even potentially, outside parapet walls. That's why there's 3 different ways to achieve your performance levels. You may have, if that's the case where insulation height could be limited because of the curb heights, I guess there's a couple different options. One would be raising the curb heights to allow for the inclusion of more insulation. And then 2 would be, utilizing the performance path to see if there's an opportunity to achieve everything you need to achieve per the energy code, while also potentially not hitting the minimums of the R value requirements in the energy code. But there, you've got to find the trade-offs that will work.
Okay, and let's see, I just have one more come through. Section C503.1, exception 6, please expand on this section exemption, or section exception.
Since I don't know the code completely verbatim, I got to look to see. It's exception number 6.
Yes, and I can always put you in touch with that later.
Yeah, I guess for the sake of time, I'd have to go take a quick look at it and see how it reads.
Okay, I will send you that. And then just a reminder, if you don't mind, Marty, if you could send me the PDF versions of these slides, we like to give them to our attendees, as they like to use them for reference and documents. And then a reminder again, February 6th is our next webinar, and thank you for joining us this morning. Thank you, Marty. That was wonderful. And I hope everyone has a great day.
Thank you all. I appreciate you guys taking the time.
Thanks. Bye-bye.
Take care.